Good afternoon, everybody. Nice to meet you here on this conference. LoRaWAN and water management. Some experiences, looking some years back, looking forward, and tell you my experiences. I'm working for a water authority in the middle of the Netherlands, here. Amsterdam, for example, is here. So I'm not responsible for your water safety today. That's another organization. And what does a water authority do? Main thing is flood protection, dikes and other measures, water quality management in the rural areas, but also wastewater treatment, and of course preventing droughts, water surpluses, the water quantity part. So far for our main tasks. And there I see a big data hunger in water management. Well, data hunger, it's more information hunger. What's happening, what's going to happen, how can we act and react? We need information, dashboard information, tailor-made. So some reasons, some drivers, I won't follow the bullets. The last one is maybe interesting. Machine learning, AI. Machine learning models are promising, growing, but they need to be fed with data, of course. They don't work out of nothing, they need data. So I see these models, this trend as also a driver for more data. We started some years already, 2017, yes, it was already years ago, with, well, we have a lot of equipment for monitoring. It was well known, worked already for years, good stuff, but expensive in buying and expensive in maintenance, and also flexible. So we thought with some colleagues and our organizations, well, let's make an open source one, the multiflex meter. You see here some places installed, an easy to install ultrasonic water sensor. It was beautiful, easy plug and play. That was my first contact with LoRaWAN, and I was immediately in love with this technique. So easy, so low power and easy to maintain. We incorporated that LoRaWAN sensors with our other data flows. Of course, you can imagine we have a lot of data, quality, quantity, weather, soil, moisture, discharge, whatever, lots of data. We combined these LoRaWAN sensors with that data flows and built, for example, for municipalities, tailor-made dashboards. Combine all the data, no matter what the source is, 1, 2, 3, 10, and also LoRaWAN multiflex meters in one dashboard, tailor-made. So it was a huge success. Enthusiastic real-time users, they were seeing real-time data, that it was new for some municipalities. So the demand for more sensors was growing. It was a success. Well, when you want to expand your network with sensors, you need coverage. You all know you need gateways or satellites, I heard today. That's where we started to expand our network. You see some pictures of high buildings. That takes time. You have to call the company. You have a high building, you want to do something with water, and please. Now you can go there, visit the roof, well, I've been in beautiful places, but it takes time. But it's growing and growing. I have now about 40 gateways. It's still growing. This area has to be filled more, but it's a going on process. With success. We don't dive only in technique, in gateways and sensors. We try to connect the organizations in the area, municipalities, schools, province, science, whatever. They have all things to do with data, not only water. And when we can benefit all from that network, the LoRaWAN network, it becomes stronger and it's shared value. Some examples, some pictures. Please read them yourself or later when you look it back, this presentation. Yeah, it's really successful. It takes time. The first start was in 2017, but it's growing and growing. People are more enthusiastic. They need to understand what's the technique, what can it bring for me, what is new. We have already 4G, why do we need LoRaWAN? Well, yes, we need LoRaWAN. Some use cases here for a municipality. They use now, it's not new, I know it's proven technique, but soil moisture sensors with young planted trees, and they really benefit from the system. These are real use case, real money, lots of money. And see more and more municipalities asking for this. As a water manager, I'm happy for the saved water, fresh water, of course, but there are more benefits, less carbon exchange, less traffic movements, etc. Next use case is working together with farmers and water management. We have the big pumps, the big weirs as water authority, but you have to do it on a little scale in a plot level. But the farmer needs data to see how have I to do that, how dry is it? You use sensors, we combine them in a data flow and build a dashboard for him or her to do the work. A new one is sewer information. The sewer system sometimes overflows when it's raining very intense, but we don't have them all sensored, and it's a big water quality problem in some areas, so we need sensors. Well, sensoring below the ground in technical, deep constructions is expensive. We're now trying to use the LoRaWAN sensors, water level sensors, to measure water levels and sewer overflows. Antenna range is a challenge, of course, but we are trying to solve that. And one new thing we are working on today is the sewer system reacts this is a rainfall event, this is a sewer level, reacts very fast, quick on the rainfall event, within minutes or 15 minutes. Here is a time series of the water level in the rural area. It's much slower, more storage. So to measure this peak, you need a very high frequency for measurement. And then your battery is done in maybe a month. So we need to solve that, to use this for sewer systems. And how we do that? We work these days on that solution. We make the measurement frequency variable based on rainfall information. Some examples, you can use here a 3-hour frequency, nothing happening. Then you use 10 minutes, and then after it, 3 hours. You can vary it per sensor. And here is how it works. We have already our water information system where all the data is integrated, also the LoRaWAN sensors. We import already the rainfall, historical rainfall radar data. We have forecast rainfall. We import already the sensors, the LoRaWAN sensors. That's the existing data flow. Now we add in the water information system for every LoRaWAN sensor. Well, for this amount of rainfall, some hours back or some hours forecasted, you need to add to use this measurement frequency. And when it's raining more, or has rained more, you use this frequency. It's just a simple table for every sensor. This is combined with a service via a downlink transmitted to the LoRaWAN sensor, and the system is looping, running. And we are building it. I'm very happy when it's working, and it's a new opportunity for working in more urban and sewer systems. Well, I explain now only a water quantity, water level part, soil moisture. There's lots more to do. For example, this is a wastewater treatment plant. A lot of technique. The bacteria are our most important employees, but there are a lot of technique here. We have pumping stations, automated weirs. We have the mobile equipment for maintenance. Lots of things to do in water management. And it's all sensored, but most traditional, wired, double wired, secure, safe, with big companies we know already for years, and not a lot of innovation. So I'm trying now to get my colleagues into LoRaWAN. You see, well, it's plug and play. You don't need to wire everything and forget it. Let's try it. So I'm working on connecting external organizations, but also connecting my colleagues into this technique to make the best of it and to get the profit from it. That's my journey last years, and it's promising. I'm still enthusiastic after all those years, and I hope I could give some insight in my experience. That was my story for today. Thank you for listening. Maybe some questions? No questions? No problem. Yes, here one.
Yes, going back to the changing the rate of the sensing and the weather according to the temperature, you said that you use the downlink to change this rate in the sensor now.
Yeah.
What problem have you encountered when managing the downlink track, because it's very limited in the LoRaWAN context now?
Which problem?
I don't know if you have encountered any problem with the downlink traffic because it's limited
Yeah.
in the LoRaWAN context.
Yeah. Yeah, we wouldn't upgrade the measurement frequency to seconds, for example. No, that's not allowed in a LoRaWAN convention, of course. Yeah.
No, but I'm meaning because you have several sensors, I guess, no? You need to update the rate of all of them.
Yeah.
But you cannot do it at the same time because the downlink is limited.
Yeah.
Or it's not a problem because
It's
you have several, the amount of gateways allows you to do this.
It's one downlink per sensor.
Per sensor.
Yeah, of course. Yeah, and in the table as I showed, we have all the records for every sensor with the required frequencies.
Okay.
Yeah.
Okay.
One sensor, one downlink per sensor. Yeah. Yes?
A question about the choice of technology, LoRa in this case. Will NB-IoT or LTM be easier and better for your case?
Yeah.
To build a network and
Yeah.
as I understand from the presentation, the sensors are located like really in a few points. And there are not thousands of them probably.
Not yet. But I'm now working, for example, with about 70 sensors. It's growing. Just bought some new ones. But I see the promise of a scaling network where the municipalities in traffic and energy, in waste, in agriculture, in whatever sectors, all benefit from an open LoRaWAN network with gateways. When I should only do it for myself, well, I should ask, why do I install 40 gateways? Just buy it, the technique, and don't bother yourself with all that gateway stuff on roofs. But I see the promise, the long term of the community, the ecosystem, where everybody can, without limitation, well, almost without, add sensors for his or her daily work. So it's an investment beyond the borders of water management, maybe. Yeah. Yeah. Yes. Thank you very much. Maybe meet you later today. Thank you.